Thank you very much. First of all, distinguished guests of the Argentinian Tunneling Association, ladies and gentlemen, thank you very much for welcoming me here in Argentina. It's my first time in South America, and I really enjoyed for the past few days just walking around Buenos Aires, so thank you very much. First of all, I would like to ask you, I'm presenting this topic, which is a broad topic that has been going on for many, many years, but it's now coming into our industry as well. So first of all, I will ask the audience, who knows anything about BIM so far, just with hands up? Okay. So we will basically, the topics that we will cover today, I have lots of slides, but these actually slides will be available to you. So, and there's lots of references there. So I do honestly would like you to go back to these slides and go deep if you are part of this community, and then try to disseminate this information to your colleagues at work. So as it's been mentioned before, I'm coming from Australia, from University of Queensland in Brisbane, and there's lots of your colleagues there from Argentina and your neighboring countries. So thank you very much for coming to Australia. We love you there. So I will go just a step back to when the whole thing started. So it's for digital engineering, we need to know where is the motivation behind it. And the key motivation was where the faults are occurring. Why are we having problems with disseminating the information from the conceptual design to the detailed design and further on to the construction and operation? So as you can see from the graph above, we have basically the project information is being lost as we transfer it from one party to another. So the key thing is what we would like to introduce with digitalization is that we would like to preserve the data and continue with traveling the data further. As you can see over there, that the blue line doesn't start at zero. It actually, the blue line would like to increase with times to go. So we would like to, with the more experience we obtain with digitalization, we would like to speed up the process of the, especially the design and then further on in the design and construct. So with that learning objective, the blue line will continue. If I may jump back one slide, I would like to acknowledge the authors of this presentation as well, which is my colleague, Professor Markus König from the Bochum University. And basically, these slides have been generated through the Bochum University, and I'm privileged to use them and basically disseminate information here as well. So why are we doing that? Because the increase in efficiency through digitalization is well known throughout the whole industry. But as we now we're coming in the construction industry, slowly digitalization is coming in. And through the course of this presentation and next presentation, I will try to outline some of those aspects. As you can see, we had a bit of a glitch there in 2009, where the global financial crisis kicked in. So it was all industries, engineering industries were affected by that. But we know that we have to be better, and we know that we have to progress onwards. So as we can see that from the levels of the digital competencies, we are trying to understand and progress with the digital transformation. So we are at the moment on digital level 2 competencies. So we are trying to introduce the use of digital knowledge in construction industry, and we would like to basically come to the digital transformation. So we were using digital tools only for our construction. So what is BIM? BIM is basically a collaborative work, as you can see it from this diagram over here, and it's we would like to increase the digital models in our whole cycle of the asset. So we would like to introduce it with our construction, and we would like to increase the collaboration, productivity, and later on transparency. So there are various ways we can describe building information modeling. Building information modeling can be described as a model, a modeling tool, management tool, a method that we apply, but overall it's basically better information management. So if we see how the progress with the development through time went, we started with drawings, and we're not trying to take the information away. We're trying to enrich the information. We're trying to build on the information of the knowledge that we have and how this information is building up. So we're trying to enrich the information. So if you look at, we have drawings. Drawings were very complicated drawings, and we would like to embed a lot of information of that. We're still doing that. We transferred from a two-dimensional drawings into a three-dimensional drawings, and we're then going into the constructability phase, which is called 4D or 5D. So, but I will go more into these details as we come. But as we progress, we can basically then proceed with adding additional information to our three-dimensional models. So we're not just discussing about the space. We are now putting numbers. As engineers, we love numbers. So we're adding these numbers so we can quantify these things. So as you can see over here, we have a given wall in a structure, and we basically can put its length, height, and width in it. So now we're building our model. So we're creating our data model. And so this is called a 3D beam. And then when we add, we basically can start adding as well when this exact wall is going to be built in our project and what is the time frame of that construction to be built. So then we start discussing about these dimensions, 4D, 5D, 6D, and so forward. So we really want to see how this progresses with time. When we do that, we can start adding cost. And that's so-called 5D. So 4D and 5D are well defined in the industry, and they're basically 4D means time and 5D means cost. And then these can evolve, and sometimes you will see in the literature it will go into 6, 7, 8, and forward. But we would prefer just to basically call it any D you want, but it's more about that we are outlining various types of quantities. In this case, we are actually outlining how many square meters of a given wall, for example, in a structure there is, so we can start quantifying how many meters we're going to have. And then we can start putting costs towards that. Not just that, we can put actually as well who's the key designer, who installed that, and so forth and so forth. So when we're looking into, I can see we're using our old slides. It will be, it's just a bit comprehensive, a bit more, so I just added a few slides inside so that you will understand why we're basically trying to add digitalization and where this digitalization come in place and how, what's the importance of it. So the key message that I will try to outline in the first presentation is, well, why are we introducing new technology and why we think it's beneficial to the current trends that we have in place. Let's see if that's, yes, thank you very much. Yes. So as you can see as well, when we are introducing beam in the environment, so if we look at the conventional planning process in our yellow, we can see that basically the planning effort is on the y-axis, and the x-axis is basically the time. So where we actually implement this. So if we do implement digitalization, we actually speed up the process. We don't say that the whole construction is going to be finished faster, but we actually say that specific information is delivered in a faster and in a faster manner, and as well you will see that when I showcase some of the example afterwards. When we look at the green line, the impact on design and the cost of the building, we see that it's a high in the beginning, and we need to invest a lot of effort into creating these models, but it's something that it's very easy later on in the time to amend. So when you look at the cost in case of any changes, and we know that contractors and the clients like to change these things, our projects, we see that the cost of changing either conventional or digital process is significant. But when and how we do it, we basically can see that by introducing digitalization, we can outline some of the processes much faster before the actual construction starts. Okay, so we basically are looking at the whole structure process of our diagram. And when we look at for the reference process, so it's very important that when we are introducing different communities into this environment, that we know the referencing process. So we know that these companies are competent and that they will be successfully implementing models into our environment. So we actually want to create various types of guidelines where we actually, they can be introduced at a given time of a project to our life cycle of the design. So if you look at the employer's information requirement, we see that we need to add information at the given time. So when we are talking to the employer, we need to brief the employer of what recommendations are needed at a given time. So we would like to create it as an execution plan which really describes those objectives of what a client wants or organization needs at that given time of the project. This is well established when we are having one-on-one discussions at a simple project, but when the projects are becoming more complicated these days and we're talking about large infrastructure projects, this execution plan is becoming very important. So we really know when a person needs that data. We create so-called use cases. Use cases are basically described tasks of planning, awarding, execution, and as well operation of various projects. And we have this type of database available online already, and you as a member nation can access these portals already. So they are basically, we are building these use cases as you saw in the beginning of that diagram. We're trying to improve that initial blue line to be higher. So when we actually proceed with tendering for new projects, we have a lot of data already available. So now I would like to showcase a typical workflow and decision points that they are made when we are introducing digital environment. So we are still doing the preliminary design phase, of course, as every other things, and we are progressing through the model. So we are doing our planning and programming, and that goes basically, it's divided into the design and construction. So we are already, when we're doing our design, we're focusing on our construction. So the process, that's where that line was shifted forward, that actually design and construction are very hand in hand in this case. So we are briefing the contractor, we're bringing the contractor on board prior to finishing the design. So these are very key elements. So if we look at how the construction was done before, we had various parties sitting behind the table and discussing and making decisions. Now that we have, I do apologize if there are lawyers in the room, but now that we have lawyers and insurers, part of these large projects, actually this division between the discussion between a designer and contractor and an operator are getting larger and larger. So we're really trying to bring that back, and this is basically the workflow that we're going through. So we're going through our planning and we're trying to build our information model. As you can see that the planning is still going forward. We're doing visualization, various types of animations, and then we as well can do various types of analysis, such as the life cycle analysis of the construction. The same goes on the other side when we're doing the standard estimating and as well the 3D takes of the project. So when we approve this design, we can then go into the design model, which actually from the designer's point of view, it's a finished product when it comes to these things. So you as a consultant or a designer basically are finishing in this area till the project is awarded. While the construction elements are progressing and we are increasing the adding information to the model by adding quantities and as well who actually will be doing those things. So enriching the model with information that before it did not exist. At that stage of building, of course. Then we continue into our construction model, which we have to validate, and we need to engage the client in early stages so that they see the model, they see how it's going to be constructed, and based on that as well, they see the flaws in that model. So as we say, we're going to have a large tunnel the size of this room, and we're going to have 1, 2, 3, 4 pillars in the middle of that room, and we're going to have 6 lanes of traffic inside. We will not be able to have these pillars over here, so something is going to have to be done. And when you do this type of model and when you go into constructability, then the designer says, no, the client says, this is just not acceptable that we're going to have pillars like this in the middle of the tunnel. And then when we basically have this finished product and the construction is finished and the model is basically uploaded into the system, then we have various types of people that basically can use the model for later on and building the whole life cycle of the project. So not just that the part of the construction, but as well later on when the tunnel is in operation and later on when it's going to go into refurbishment as well. So how do we transfer all this data? This data is done in so-called CDE, or Common Data Environment. It's an environment that it's proposed initially by the client and with the support of the consultant, and this is the environment that everyone communicates through. So there are various types of model, which are various types of tools that are available for us to use, and some of them I'll outline before, but it's just an understanding that I'm trying to bring, that we need to create an environment where individual parties can communicate, and we're talking from the client, owner, and all the way down to the operator. When we're coordinating these disciplines, we basically are going through the process of enhancing everyone's contribution, and we are asking them, bring the best tools to the table, bring your knowledge to the table. Let's try to put everything together so that we see how well we can enrich the model. And when we have parties from various fields coming and they're bringing their best technology in, basically we want to incorporate that. So it's called the so-called a federated model. So that's a model that basically consists of enriched data, and that's the data that we would like individuals to use for every stage of the project. I'll show you some graphs later on, because I have 2 more presentations today, so apologies for that. But you will see how maybe you think that I'm living in a fairyland, but some of the things actually are happening, but some of the things are still to come. But in your head, there are 2 things that I've introduced already. One is a common data environment, and the other one is that within this data environment, we have so-called federated models. And these federated models are basically contributed from various disciplines, and they are coordinated. So, of course, we just can't say that anyone can do anything in this common data environment. So we would like to give individuals tasks that they can perform at any given time. And we ask these individuals to contribute at that time. So we're asking them to contribute, exchange explicit information. Some of the things probably you can't see, but it's no point in that. You can still later on have a look at these slides more thoroughly. But new positions are becoming available. New disciplines are developing as part of this information delivering. So we're not taking away the existing roles. We are enriching the roles, plus we're creating new roles. So in these terms, we have new roles created, such as a BIM manager, BIM coordinator, and BIM modeler. We do not say that individuals cannot take these roles up, but we do suggest that with upcoming projects, new positions are becoming available, and we need to create new positions within companies that they are strategically focused on how they look and how do they observe these competencies. So if, for example, we look at the manager, a manager should not intervene what for example, a modeler is doing. That's BIM's coordinator thoughts. Of course, if we're talking in a small company, an individual can have all three tasks. It's not a problem, because then it's the bigger the project is, the more objectives we are overlooking, the harder these things come. So we're basically creating various BIM managers in this environment. So all of this data that is exchanges, it needs to be standardized. And these various industry foundation classes are available already. And currently we're going into the process of developing IFC for tunnels, and I will introduce that shortly. But if you look at, we want to exchange this model. These models are very enriched model. They are three-dimensional models. They are GIS connected models. They are connected models with various information data. So if you can imagine just exporting an Autodesk Revit, new version of Revit into an older version of Revit. It's very hard. For those of you who are dealing in this environment, you know that even that is becoming harder. So we know that the technologies are developing really fast. So this type of information and this type of standards are very important, so that we know that when we are uploading these large files, they are not losing data when they are in the common data environment. So when we look at how the whole thing happens, is that we basically have our geometries and we have various types of data that is coming in. We need to know how this data will be changed, so it's going to be standardized by the Building Smart, which is an organization. It's a national organization like ITA, that it's overlooking at various types of standardizations around the world. And when we do this transformation, then we can start using all of our tools in this BIM application database. So now that we're going towards the disciplines that we are dealing with, we need to highlight that the tunnels are different. Tunnels are different than structures, and we know that. We are in this industry, we love this industry, and we need to be vocal now that we make changes as we go. And that's what we are introducing as we speak. So if you look at the bottom, just as we speak, IFC or industry foundation classes are being designed for roads, rails, bridges, as well as tunnels, and even so it's for marine, so for piers and marine adjacent structures that they exist. So this is very important that we have our IFC tunnel design included in this, because for us, geology is the most important element of construction. So we always need to come back to the fundamentals and say, how does the tunnel and bridge differ? Yes, we use concrete, we use a lot of concrete, but the way we interact with the geology is fundamentally different. So for us, it was very important to introduce this tunnel design IFC, which we push forward through ITA. So now we're going to go through some of these federated models, and I'm just basically going to start introducing that we're going to go into non-linear structures. As you all know, we will be dealing with lots of geology, and we will be dealing with interfaces. So we are dealing with objects that are structures, such as bridges. We are dealing with embankments. We're dealing with various geologies. We're dealing with water and lots of monitoring systems. So all these models are done in a way that they can be changed every meter of the advance of the tunnels. We all know that our dimensions of the tunnels are changing with our alignment, and we basically know that every chainage that we are continuing excavating is different. So in aspect, we have basically every meter of the tunnel is its own structure. So we want to put all of these together. We have level of development. So for all these models, when we are discussing with individuals, we don't want to say that we need so-called level of LOD, as it's called, level of development, to the high precision as we see over there. Sometimes it's enough just to say that we need a specific annular gap space, and we know that the lining is going to be inside, and we know that there is going to be some interior space that we're designing. So at a given stage of the construction, we want to know what is the level of development that we require from a consultancy, from a contractor, from a supplier to provide us with. So when we have this in our models, there is one very interesting thing that we can do. It's basically called clash detection. So we basically, when we put all these models together from various coordinate systems that we are using into the common coordinate system, we see that there are specific areas that clash. And for example, we see over there, and as part of the construction, we can already address that, because we know that a specific facility will come there in that place, and we can speed our construction in the time of constructability, not that we come and then cut that piece of concrete when time is due for that pipe to go through. So we have various types of use cases already established, and one clear space is basically how we're doing our space alignment spacing. So where do we going to place our alignment? How our alignment is going to interact with existing structures, and how will that basically have a focus on the structures that are adjacent to that construction. So we have then various types of use cases. They're overlooking at what type of structure are adjacent, on what type of structures are needed prior to our construction to be built. So for example, in here we're looking at a deep excavation prior to our cut and cover being built. And then we are using as various types of management tools that they are available that help us throughout the course of the construction, and as well throughout the course of the operation of the tunnel build. So we have all of these tools that they are already available that we can use, and they are so-called use cases available for you to use, to download, and basically implement onto your design. So now we always get asked, how is BIM compatible with GIS? So Geographic Information System, it's well developed, it's been there for many years. We use it, everyone is using it in our industry, but of course we are enriching that model. So as you see, we are going through so-called 2.5D, as we talk about those Ds again, and we're going towards our 3D models that we are currently seeing on. But that all has to be interchanged and basically compatible with one another. So if we're looking at our GIS through the process of various layers that they already exist, from topographic maps to geology to land use suitability and various things of where GIS is very strong. We want to use this data, we want to enrich this data. So we're basically integrating our BIM structures in, and tunneling, surveying methods are all integrated in this. So, and that's something that I'll showcase with you later. But as you can see, that this is becoming quite structural. So the more information we have, the more we can use it. We will have today an actual presentation about tunnel boring machines and how well they're integrated and BIM is integrated with GIS. So I will not be discussing about that. I just wanted to basically say that we have every element of the tunnel construction on this table, and it's well interconnected amongst each other. So it's not just that we're doing various activities around the design, but it's well interconnected, and we're using the data that we're producing. And for example, when we look at just an example of integration of BIM and GIS, we have our GIS photos, which consists of geology, alignment, various types of parameters, and buildings that they already exist, and we basically combine them with CAD models. One thing which is very important about BIM is that we're introducing BIM so that we can do something with it as well, which is not just that we are collating all the data. We want to then use that data and that enrich data and use it for various types of models, such as a finite element model in this case. So we want to know what our settlements will be when our tunnel boring machine actually passes under the building, and that can be in advance calculated. So if you think that the owner of that building will not be happy with that given settlement that we are predicting, we then shift that alignment, as every client will say, we are not able to go under that building because of the historical issues. For example, the model that we're changing, we are basically changing all the data as well. But because we are in the common data environment, because we are dealing with standardized information that we have, it will not have a large effect. So in summary, building information model has great potential for tunnel construction, and I will outline that in the next presentation, but we already see that it can be applied today. So in particular, the visualization of complex situations in order to assess possible risks more accurately, and as well in development in the field of standardization and further experiences of applications of BIM in tunnels constructed are still necessary. So all of these tools are still being developed, and we're basically looking for very innovative solutions that we are dealing with this large data that we are producing on a daily basis. So just for your information, as part of the JTES, we are asked to create this type of presentations for you to use and for you to disseminate it amongst your colleagues. So all of this information is available, and it's going to be given to you in any format. I'm not sure how, but usually it's on the JTES website documents. And part of this process of education is that we inform member nations around the world what individual members are doing. So, and as well, what are the publications that they are currently used, such as standards, and as well as books that they've been published in these domains. So maybe the topics that I've covered now in this past half an hour, we teach at universities, and we teach them for the whole semester, and we only touch base the fundamentals when we teach the course. Here I've done a whole overview of this in half an hour, but basically now I will go to my next presentation, which is focused on BIM in tunnels. Thank you.
Thank you, Yuri. Shall we make some questions? Okay.